So in our previous discussion, we have discussed what is corrosion, types of corrosion, and we have discussed how wet corrosion is classified further, isn't it? And we have also seen the factors affecting rate of corrosion. So corrosion is not restricted only to one particular area or region. It's a universal problem. We are supposed to control corrosion or prevent corrosion. So how do we prevent corrosion? So if it is iron, we prevent corrosion by painting. So there are various other methods how to control corrosion. So it's not only to iron, it's applicable for any other metals too. Let us see what are different corrosion control techniques available, and let us discuss one by one in our today's discussion. Various corrosion control techniques available are galvanization, metallic coating, anodizing, cathodic protection, anodic protection, etc. So metallic coating, or it's generally called coatings. So coatings might be once again divided into metallic coating, organic coating, and inorganic coating. So we have organic coating as paint, inorganic coating is different. Okay, so metallic coating. So depositing a layer of one metal on the surface of a base metal is called as metallic coating. Coating a base metal with a metal is called as metallic coating. What do you mean by base metal? So if you want to protect this metal from corrosion, then this is called as a base metal. The metal to be protected from corrosion or the metal to be coated is called as base metal. Okay, so the base metal. So metallic coatings are further divided into anodic coating or cathodic coating. So the base metal, if you're coating a base metal with metal which acts as anode, it is called as anodic coating. Now the metal which is coated with the base metal is coated with a metal which acts as a cathode to it, that is called as cathodic coating. The base metal is coated with a metal which acts as anode, it is called as anodic coating. If it is coated with a metal which acts as cathode to it, it is called as cathodic coating. So we don't have this classification further, but we have only galvanization process. Okay, coating a metal which acts as anodic to it is anodic coating. Example is galvanization. So what is galvanization? So coating zinc on the surface of base metal or iron or steel in order to prevent from further undergoing corrosion is called as galvanization. So let us see how this galvanization is carried about. Going to take a base metal, so dip it in organic solvent. So why? So you're supposed to clean the surface. First cleaning is very important. When dip it in organic solvent, the oil, grease, everything will be removed from the surface. Later it will be dipped in dilute sulfuric acid. When dip it in dilute sulfuric acid, if the metal contains any rust present over here, it will be completely removed. Then it will be dipped in molten zinc. So when you dip in molten zinc, so this is called as hot dipping process, just dipping. So the galvanization can be also done by electroplating process, electroless plating. So this we discuss in our next topics. Okay, next is further discussions. Now dip in zinc, what will happen? Zinc will get coated on the surface of the base metal, but it will be uneven. So you're supposed to have an even surface of zinc deposition on the metal. So what do? You're going to pass this article in between the rollers. When you pass, so you want 1 mm thickness or 0.1 mm thickness. You're going to pass in between the rollers. When you pass in between the rollers, the excess of zinc will be removed. So once the excess of zinc is removed, you're going to, the deposition might have pores. So we're going to dip the article in hot water. When you dip the article in hot water, the pores will be closed. So the galvanization is usually done industrially. So how this galvanization process is done industrially, have a look using this video. Okay, so you might have visited any of the railway stations nearby to you, right? So when you visit a railway station, it might be a few railway stations which is, almost all railway stations in Bangalore have electric trains. So if you want to run electric trains, what is main? Essential is current. For that you should have poles, right? So if you have a vertical poles like this, from this you have horizontal wires. So these horizontal wires supply current. So these vertical iron poles are galvanized. So those are iron poles which that silver color, that is nothing but coated with zinc. Those are galvanized. So just have a look how these iron poles are galvanized. So they are just dipping it. So this dipping meant hot dipping it in molten zinc. Not only in railway station, you can see on our flyovers. When you go on flyovers, you'll have lights, right? So those are also those poles which give you street lights like this. So these poles are also made up of iron but coated with zinc, galvanized iron pole. So let us have a look how these poles are galvanized industrial. Done. You can see these poles, iron poles, will be dipped in zinc. Once it is dipped in zinc, it will come out. You can see the color. Okay. Iron poles will be dipped into zinc. You can see how it is dipped. It's dipped in molten zinc. So it is dipped, it is called as hot dipping process. It is dipped. Now removing it, you can just see, have a look. After dipping, it will come out. Just have it how it will come out. It will be removed. I'll just show you how it will be removed. You see, slowly it will be lifted using robots. So when the poles come up, you can see the poles, iron poles with lustrous surface. Yeah, I think you can see now. These are galvanized iron poles. See how it was and how it is. It will be completely moved top. They are lifting it slowly. That is the tip, that's the other side. The part which is inside the, which is coming out now, it will reach the ground. Okay. This is how the iron poles are galvanized industrial. This is a small video where hot dipping process is done. Galvanizing for nails. Okay.
The challenge in galvanizing bolts is preventing zinc buildup in the threads, which can prevent nut assembly. Portland bolt uses
Yes, sir. Yeah.
hot dip galvanizing is the process of metallurgically bonding zinc to steel to prevent corrosion. The challenge in galvanizing bolts is preventing zinc buildup in the threads, which can prevent nut assembly. Portland bolt uses a specialized galvanizing process to ensure clean threads. Some bolts are blasted with steel shot to remove the excess forging, heat treat, or mill scale that can prevent the zinc from bonding properly with the steel.
This is also done industrially, but for small articles. It's not, I mean, yeah.
They are then rinsed and submerged in sulfuric acid, which etches the steel so the zinc can penetrate the surface. The bolts are rinsed again, then submerged in flux to facilitate the bond between the zinc and the steel. The bolts are then transferred to baskets or racks and submerged in 840-degree molten zinc for 2 to 5 minutes, depending on their size and grade. The bolts are removed from the zinc and rapidly spun. Centrifugal force removes excess zinc from the threads. The bolts are cooled in water tanks, inspected, and packaged for shipment.
It is cooled, it
Portland
is
Bolt's
poured in water
specialized
in order to
galvanizing
close
line
the
gives us
pores.
control over the delivery schedule and ensures a trouble-free nut fit. For more information about hot-dip
All these
galvanized
are
fasteners,
galvanized.
contact Portland
Okay.
Bolt.
Yes. So next we have anodizing. What do you mean by anodizing? So anodizing is nothing but you have aluminum, right? As I told you, aluminum. So when aluminum comes in contact with water, the corrosion product, whatever is there, is highly insoluble, non-porous, right? So the nature itself forms, the aluminum oxide formed, it will protect the metal from further undergoing corrosion. If something is ruptured, once again it will develop the corrosion product, it will protect. But what is happening, this cannot be used for industrial purpose. So this should be used for industrial purpose, the thickness should be more. So the process of increasing the thickness of oxide layer on the surface of passive metals by making the base metal as anode in an acid media is called as anodizing. The entire anodizing is nothing but to increase the thickness on the surface of passive metals. What are passive metals as discussed? Aluminium, nickel, tungsten or chromium. So these are passive metals. So increasing the thickness of the oxide layer on these metal surfaces by making those metals as anode in acid media is called as anodizing. So let us see how anodizing of aluminum is done. So the metal to be anodized is cleaned and it is made as anode. And the inert metal is made as cathode, and the electrolyte, and both are dipped in sulfuric acid or chromic acid. These both are connected to external power supply, that is DC, and around 40 volts power supply is given. At 35 degrees Celsius, the anodizing will occur. What are the electrode reactions at anode? At anode, what will happen? Aluminum undergoes oxidation and it will form Al2O3. That Al2O3 will be deposited on the surface of anode. There is a small animated video which shows the anodizing process. Just have a look over it. Okay, including the cleaning process also. After anodizing, it will be dipped in hot water. So the aluminum will have a small pores. In order to close those pores, it will be dipped in hot water. The pores will be completely closed. You can just have a look of the anodizing process here.
So let's cover them one by one. First, the aluminium substrate is mechanically treated by polishing or blasting with glass beads. This is important. Hello science enthusiasts, you are watching a Captain Corrosion video about anodizing, and in this episode you will learn about the basic steps that are required to properly carry out this process. So let's cover them one by one. First, the aluminium
This is first pre-treatment.
treated
The articles to be anodized are pre-treated.
This is important because it helps removing the poor quality natural oxide layer and most of the impurities that would hinder the formation of the anodic oxide layer. Then the metal substrate is cleaned from loose particles and minor impurities by rinsing with deionized water and organic solvents. In the next stages, the aluminium substrate is treated with warm sodium hydroxide and nitric acid in order to chemically remove the top layer of the metal, which results in a very clean surface and also exposes near-surface intermetallic particles. It should also be noted that the chemical treatment stages are sometimes not necessary if the mechanical treatment is already sufficient. Anyhow, the freshly treated metal is then anodized, where the anodizing parameters
There will be small pores, you can see there, right?
Temperature,
This pore should be blocked.
are selected based on final application. Finally, the pores in the anodic aluminum oxide layer are normally sealed to achieve long-term protection against corrosion, improve the resistance against mechanical damage, or to simply apply an aesthetic appearance. This can be done, for instance, by hydrothermal sealing, paints, or a variety of alternative methods, which will be discussed in the next episode.
So these anodized articles, where are they used? So they are mainly used. Anodized articles are mainly used in escalators, your window frames, right? Yeah, your satellites. So all these things, this anodized aluminum is being used. Okay.
Thank you for watching our video about basic steps in anodizing. If you want to learn more about this topic,
Yes. Thank
please
you.